throws you something, the output of your mapper function is what we call it as intermediate key value pairs. So let's understand that. So MapReduce itself will go for a few sessions, but basically go ahead, understand the process of what does this logic apply. So here in terms of word count, so what you will have to do, and read all the input and then produce the output. So output is nothing but your intermediate key value pairs. So what we mean by key value pairs? Key value pair is nothing but a key and a value. So which means you can compare it as a dictionary data structure or a hash data structure where you have a key and corresponding value. Similarly, you have something called key value pairs that is primarily used for the data processing, that is data that is being read as an input and the intermediate key value pair and finally the output also. So the output might not really be key value pair, but the intermediate and the input should always be key value pair. So let's understand that. Yes, so once we have done the mapper, so we have something called, we do a line split. So once you do the line split and tokenize it, so the in the mapper function, you actually tokenize the words. So when you say tokenize the words, if you give 100 lines of text file, so that file once it is processed, each and every word split by white spaces and all other unwanted junk characters like dot, exclamation, all other things, it would be utilized to be considered as a word. So that is what you call it as your mapper function. Here the logic would be to tokenize that and then add a 1 to each and every key value pair. So which means whatever be the word I am going to encounter, that word comma 1 would be used. So that is what mapper function is. Reducer function is something that you'll have to understand in terms of again key value pair. So previously mapper function have given you a lot of input the output intermediate key value pairs, right? So that intermediate key value pairs should be aggregated together, or it should be available to the reducer as a group of key value pairs uniquely identified by your key. So that is what you call it as reducer. So let's understand that. Explain you this basic session. So but this takes some time to digest since we already have MapReduce is something that you'll have to understand and realize that in terms of mapping and reducing, but this should be fine. So let's understand that. So basically when you say MapReduce, if you can clearly understand what was the HDFS concept that we have seen, it would be the file size that I'm going to give an HDFS that would be partitioned into several smaller blocks of data. That is what you call it as 64 MB blocks by default, your HDFS block. So those, when I am going to give 1 GB or 650 MB of data, that is, if I say your 64 MB of block size is a default size, so how many number of blocks we get, HDFS blocks we get? 650 mod 64, so which means you get around 11 blocks. So which means 10 is something, for 640 you get some 10, and plus the remaining will be considered as another block. So that is something that you will have to understand. So that's fine. So you have something called input key value pair. Each and every input that we write would be actually processed by your mapper. Each and every input that is all available from your data that we have fed in, so that is converted as HDFS blocks. So each and every block would be processed by your mapper functions. Your mapper functions are something that is going to actually work on the input data set and process the initial logic that we have written in mapper. So what is the initial logic we have written? We have said something called tokenize the word and add the key value and emit the key value pair as key comma 1. So that is what the funda here. So in that sense, this HDFS data would be processed and mapper function would throw output called D comma 1, brown comma 1, fox comma 1. So take a very simple example here. So this is not really essentially 64 MB of block data, but essentially this will give you a clear picture of what is the whole funda behind that. So when you say 64 MB of block data, the quick brown fox, so what does this mean? D comma 1, quick comma 1, brown comma 1, fox comma 1 is the output that we can see. So this is what we call it as intermediate key value pairs. So when you say intermediate key value pairs, what does that mean to you? So you need to understand something called intermediate key value pairs are nothing but the actual output of your mappers function. So this intermediate key value pairs will go through a process called shuffle and sort. So this is something very crucial and very important scenario in your MapReduce function. So your mapper does some understand some read the input data and then process the output data. So in that sense, so what essentially does that mean to us? So it also does something called shuffle and sort. So what do we mean by shuffle and sort? If you can clearly notice, you have many mappers here and you have a number of HDFS blocks here. So once one block has been finished, okay, so this block also has been finished, which means like you might have some hundreds of HDFS blocks in the queue that needs to be processed. So which means once this is processed, this output key value pair is produced and then you have it. So basically once this is processed, this will be produced. Once this is processed, this intermediate key value pairs would be produced. Similarly, so this intermediate key value pairs would be collected then and there by your shuffle and sort. Basically, your intermediate key value pairs would be generated and it will all be kept in the buffer. So once every input key value, your input data set, that is your HDFS blocks, has been processed, your all your intermediate key value pairs would be shuffled. It will be collected together, shuffled, and then sorted based on the keys. So the process of shuffling and sorting is to minimize your whole process. That is actual magical step that makes Hadoop to be standing out in terms of MapReduce and making things more relevant and making things more efficient. So the whole important feature behind MapReduce model is a shuffle and sort. So the shuffle and sort will be working on all the intermediate key value pair and it will actually sort things out based on your keys. So that is what you call it as shuffle and sort. So once you get the shuffle and sort ready, so shuffle and sort will actually collect all the intermediate key value pairs produced by the n number of mappers previously and right now. So it will be collecting all that together and it will be shuffling. So which means in terms of sorting, so it actually sorts your all your key value pairs and all your key value pairs would be sorted based on the key. So in that sense, when you say like even though you have thousands of key value pairs that is all generated at some point of time. So take an example, the comma quick comma brown comma fox. Here the comma one is created, brown comma one is created, fox comma one is created, quick comma one is created. So here in that sense, rather than telling okay your mapper function does process this first block as a whole picture and then give it directly to the reducer, no, that is not the case. So you also have something called the fox ate the mouse. So here we see the comma one, fox comma one, the comma one twice, and then 8 comma 1 mouse comma 1. Here you have the number of the words called the as 2. You have twice the number of words called the. So here in that sense twice the number of words called the, the word the occurs twice. So that does not mean like so okay this is what the final output of the. I can't really say these the comma 2 is your word count of it because you already have one the available here. You might also see some other the in the upcoming data block, so which might be in the queue to be processed. So in that sense, the shuffle and sort is an intermediate place where it says whatever be the mapper functions that is all completed or getting or completed right now. Before going to the reducer stage, your shuffle and sort will collect all the intermediate key value pair sorted based on the keys. Once you sort your intermediate key value pairs based on the key, you can group all your key value pairs like this. So you can actually say d comma 1, d comma 1, d comma 1, all it will all occur together rather than as d comma 1, quick comma 1. So if you say like the word count, so this input document, the whole document will have some hundreds of these. So in that sense, your hundreds of these would be occurring sequentially, right? So it will happen at some random point of time, and so that needs to be collected and that needs to be identified. So that is where your shuffle and sort comes into picture. It actually shuffles all your intermediate key value pairs and then processes it, and then given it needs to be sorted all together, and the sorted intermediate key value pairs will right. So it is all sorted based on the keys. So the based on the keys you have something called groups. So those key value pair groups, we call it as a group of key value pair identified by unique key. So which means d comma 1, 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 so up to 100 d comma 1s. So you call this whole group the key, this key value pairs of several these, right? This is what you call it as key value groups. So these key value groups would be given as a whole, not as a partition. So you can't really split this key value pair in the middle, like 50 key value pairs would go to the one reducer and the remaining 50 key value pairs would go to the another reducer. No, that is not the case. Here, why do we need to sort and group the key value pairs is to make sure that whatever be your key, That is, your group of keys should not really be partitioned in the middle. Rather, your group of keys should go directly to a reducer as a whole picture, not as a splitted picture. So if you can clearly understand that, so which means like you can identify or we can get the output clearly like this brown comma 2, fox comma 2. So if you say like if you don't have shuffle and sort, now probably d comma 3 might not really be available here. We might see something called d comma 1 here. We can see something called d comma 2 here, but that is not the desired output, right? So because only if you can actually give the whole key value per group into one single reducer, it can aggregate things. So when you say reducer, reducer is an aggregation factor. So what does reducer do? For each unique key and the values that it has, 1 comma 1, 1 plus 1 plus 1 plus, so it aggregates or adds everything together and it actually displays the output. So that is what the funda of your reducer function is. This is what you call it as basically a map. Yes, please go ahead, Arish.
Yeah, I have a quick question. I mean,
Yeah.
in the diagram, what we are seeing, right? Like we have the input map and shuffle and sort. So,
Yeah.
so we are getting this temporary, where, or you could say that these computation is being done temporarily, holded, and then sent or passed on to the reducer, which is further, basically aggregating and sending it to as output. Right?
Yes, yes.
So this shuffle and sort, does it use disk space or does it happen in memory?
Shuffle and sort happens in the memory. So basically, like more than calling it as happening in the memory, basically each and every mapper function, right? So you'll be understanding this in very detail later, but I'm just going to give you the answer. So you have something called n number of mappers, right? So mappers are nothing but your data nodes. We have already seen something, remember? We have a component called data node that takes care of the like it also it has another component called task tracker, remember?
Yes, yes.
Yeah, so the task tracker is responsible for getting all your smaller tasks given by your job tracker. So this task tracker would be executing things. So your task tracker is nothing but a worker node. So in that sense, the task tracker can be used as a mapper during the initial stages, and later after that it will be used as a reducer. Got it?
Yeah, got it.
Yeah.
So,
In
so,
that sense,
so
your each and every mapping function, right? So each and every mapping function would be producing something called an intermediate key value pair. Then and there it has processed its own blocks of data. Okay, so those key value pairs would be available locally in the local file system in your mapper function, and that key value pair would be collected by this process of shuffle and sort then and there. Once your mapper function has been collected, so which means the task tracker is available for the next mapper function, right? So that data would be collected and kept. So those data, once everything has been aggregated, so once everything is all collected, so till your last mapper function, all your data would be collected and then shuffle and sort happens.
okay. So,
Yeah.
so, so I mean, I'm just throwing up a question like, okay,
Yeah, please.
let us say we have three compute nodes or three mapper or three work nodes or data nodes. Okay.
Okay.
So we started off three jobs. Okay. So these three jobs, with a replication factor of three, uh, these three jobs are actually sent to the same three data nodes, right? So so let us say the same compute node is actually now has three task trackers, which in turn gave rise to three job trackers. That means there are three jobs running, but they are different MapReduce programs
No,
running
no,
on the
no.
same compute
I don't get that clear. Please come again.
node. What I'm
Any
asking is,
map reduce any cluster, right? It will take only one job at any point of time.
oh, so you're saying that
Job
basically,
is one. Make this clear. You call word count as a job, but your mapper logic is what you call it as mappers. You have concurrently a number of mappers running, but what you need to understand is you can in any point of time your Hadoop cluster can run one map reduce job only.
okay, so that's a
So
limitation
when you
to
say
something.
one map reduce
So
job, this map reduce job can concurrently run several mappers, several reducers.
agree. I got the
Okay,
way
okay.
you're
Go ahead.
trying
Sorry. Yeah.
interpretation. So I'm just coming back again. So let us say. now the example what we just saw is a word count execution example, right? So somebody
Okay.
built a map reduce code. He built a
Yeah.
mapper, then a tokenizer, then he is doing shuffle shot, and then he's going to output, right? This is an example of
Okay.
word count. Now
Yeah.
I'm coming different thing, and what I am doing is I'm not doing word count, but I'm giving completely a different thing where I'm doing a frequency number count based on
Okay. Okay. Yes.
numeric input. Okay.
Yes.
Now, now does this mean that until unless can both the jobs be submitted to the same node? Yes or no?
No, not essentially. So basically, whatever be your logic, so whatever you are talking, right? So you say like, okay, I'm planning for a not a word count example, but something called a frequency analysis where my logic will differ. So what is the difference that it makes here? That is what your question is?
No, no, that's not the question. The question is, can I run multiple programs? Like now, can I run multiple job, this MapReduce program on the
Okay.
same node?
Yeah, you can run on the same node, but essentially at any point of time, only one job can run.
Okay, so when you say at any given point, so let us say you are user A, I'm user B. You are doing the word count. You started the program for word count, the MapReduce.
Yeah.
I am
Yeah.
I am some other guy in working in some other department. I started another program which is not word
No, it
count,
will
but
not
it is
work. It will not work. It will reject or it will be, because when you say
it
Hadoop,
would.
Hadoop is meant for batch processing, correct?
Okay, exactly. Okay. So yeah, exactly. So that means this is more like a batch processing, and the listing and the first in first out model happens on the name node.
Essentially, because that is meant for that. Because when you say Hadoop, Hadoop is not something for real-time processing where you have 10 people who are going to query on things. Because this is not a database system where you can actually like where a number of people come in to actually query things. Rather, it is more of a processing unit or it is more of a intelligence system which might actually deal with large data sets and derive or get some output for you. So these are all
Okay.
something that
So
you have to understand.
even
Yeah.
though even though the programs are different, even though the data set what they are going against is different, but still they are going to be only sequences.
Yes.
Okay. Okay.
Yeah,
Yeah.
that is
I,
what the
I think
funda is.
that explains.
So,
Okay.
yeah, that is what the funda is because whatever be the complex logic you take, you can just forget about how it is represented because here you are not just a user, but rather here this when we say this architect level training, you need to understand what are all the niche areas where you will have to understand. So when you say input, input is end of the day will, but the mapper logic, right? So we have already seen here, right? So the mapper logic considers the input as a line or some kind of content asset on my file, correct? But these complexity is all totally here. Here, even when you take your
I
Java MapReduce code, this complexity would be totally abstracted because your framework itself takes care of it.
okay.
Splitting
So
your
so the
file into several blocks,
right,
framework itself
right.
does a heavy lifting. So we can just concentrate only on the logic, and when you can understand the whole process, you can think in terms of mappers and reducers and key value pairs.
Okay. So that means eventually what is happening is you can submit only one job. It has to let it complete. Then only
Yeah, yeah,
the
yeah, right.
second.
Right.
Okay, got
Basically,
it.
Hadoop is meant for that. Yeah, yeah, right.
Okay. So can we do that like, okay, let us say I have ten data nodes, or let us say 10 work nodes. I
Okay.
can submit a job in the first five to go after the word count, and I can submit a different job on the next five.
No.
Can that be
If
possible?
that is the case, yeah, that is what. To clearly give you a picture, so in that case, you can set up one cluster with 5 nodes, the later cluster with another node. One cluster can take up only one job at any point of time.
Okay. So one
Because
cluster
when
can
you
only
say
take
name
up
node, right?
one.
Name node needs to maintain the namespace ID, right? It should not really get confused about things.
Okay. So basically name node is basically always maintaining the consistency of what the process has been triggered and where the
Yeah,
data is going. So that's why it,
exactly.
it can only focus on only one job at a time.
Yes, that is the reason.
Okay.
Yeah,
Okay. Got it.
because
Thanks.
that is what the requirement is. It is not required to actually run 10 Hadoop because when we can clearly understand Hadoop is primarily meant for batch processing, we'll have to understand.
Okay. Thanks.
Yeah.
Okay,
Right. So
I have
let's
a
understand
question,
some more
Saran.
details, and we'll actually continue with this map. MapReduce is a bigger concept. We have few other components. Understand this concept, digest it, and let's understand. Okay. Yeah. 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 Rakesh, please go ahead.
Okay, Saravanan, like when you have done the map job, you have divided the entire line into bits, into words, and then again you
Correct.
are transporting it uh, on the network and sending
Rakesh,
it
go
to
ahead. I'm
reduce.
listening.
Okay, like in map job
Jay,
you
are
are,
you there?
sorry, are you able to hear me? Are you able to hear me?
No, no, no. I have just stopped. I'm waiting for Rakesh to raise a question.
Oh, okay. uh, my question is, when you are doing map jobs, like you are dividing the entire data into words, and again you are transporting it to the reducer, so essentially you are carrying a large amount of data over the network to reducer. Okay, 1 second.
No, Rakesh, I'm not able to hear you. Can you just type in your query? Because I believe previously you were able to talk, right? I was able to hear that. Yeah, after your mapper has been completed, each and every mapper, so it is not just one or two mappers, so you might have 100 mappers also. So when you say if you just have, like, which means the data, your HDFS data would be might be split into 100 parts. So which means even though you have three mappers, so that using the three mappers you will have to process that 100 mappers, so that output should be collected together and it will all be used to shuffle and sort, and then that output, once you get it, so it will be sorted and then it will be given to your reducer. Essentially, yes. So that is not going to happen on a larger scale, but it would be more of a serialized structure. Your question is right. So it is not really going to be in terabytes, as if like we are not going to move terabytes of data across the network right away. So you have few other functions. Your question is absolutely right. I really appreciate that. So in that sense, we have few other functions that we'll be seeing. So as I have clearly said, MapReduce is an even bigger picture. We have the next few classes covering that up. Yes, so it is not terabytes, but it is more of a serialized data that will be moving across places, across your reducers, and so to get things shuffled, collecting things up, then you partition it, and then you actually minimize the load. So there are few optimization techniques comes into picture.